In 1859, Charles Darwin's book On the Origin of Species was published, outlining the theory of evolution by natural selection. But one feature of the natural world that this theory had not been able to explain was why some species have what seem to be decorative features that don't enhance their survival. One example would be a peacock's tail. It's very beautiful, but why should beauty be favoured by natural selection? Beauty doesn't help you to survive. Darwin found the inability to explain this so frustrating that in a letter to a colleague he complained that the sight of a peacock's tail made him sick. The answer he eventually came up with, though, was that selection can favour features that help an individual to reproduce as well as just to survive, and that includes features that make you more attractive to potential mates. In terms of selection, it's no use being great at surviving if you can't attract mates, because no matter how good at surviving you are, if you don't reproduce, your genes will not be passed on, so you have to be able to do both. Sexual selection is the selection that results from competition for mates rather than competition to survive. And it can even act in the opposite direction from natural selection. For instance, if brightly coloured feathers like a peacock's make an individual more attractive, but also less camouflaged against predators, then there's a trade-off between those two opposite selection pressures. So animals evolve ornaments like a peacock's tail because they impress potential mates. There are absolutely thousands of examples of ornamental traits. One clear example is the birds of paradise, a family of birds living in Australia and Papua New Guinea, who have really amazing colourful feathers and striking courtship dances as an ornamental trait. Ornamental traits can take other forms as well, such as in bowerbirds, where males build a nest and gather collections of brightly coloured objects, and females will come and inspect the collections and choose a mate based on that. These examples are both birds, but this kind of thing is widespread in the animal kingdom. An example from invertebrates that's often shared online is jumping spiders, which have a really adorable courtship dance, which I'd recommend looking up if you haven't seen before. But important question, why would you be interested in colourful feathers in a mate? Why is it more attractive than plain feathers? Or why is it so great that your mate can do a special dance? Who cares? One early criticism of Darwin's theory of sexual selection was the argument that it supposedly required female animals to be able to make an artistic judgment as to which mates are the most aesthetically pleasing. And it was thought that this was a ridiculous assumption. However, we can explain these preferences without having to make assumptions about the aesthetic tastes of animals. One reason is that an ornamental trait like a peacock's tail can be a signal of good health and nutrition. Just like how if a human is healthy, they might have really long, thick, glossy hair, and if they were getting sick or older, then their hair might start to fall out and look thinner. So by having this really exaggerated tail, a peacock gets to really show off what a great condition his feathers are in, and therefore how healthy and fit he is. And that would suggest that he'd provide good genes to the offspring and maybe also be able to provide a good quality of parental care. So if we imagine two peahens, that's female peacocks, and one prefers to mate with males that have this showy, colourful tail, and the other has no preference, then we'd expect the first peahen to have chicks that were healthier, because she would have selected a better quality father for them and they'd have better genes. These chicks would then be more likely to survive and have chicks of their own. And importantly, this doesn't require that the female knows or calculates that choosing a mate with a colourful tail will give her better offspring. If she has this preference for whatever reason, even if she was a complete automaton and didn't know what she was doing, she'll on average have more surviving offspring. And so that preference will be selected for an increase in the population if it's heritable in any way. There's another way that having this preference might be selected for in peahens. Let's say the peacock's tail actually doesn't tell us anything about his health, it's completely neutral, but we do know that some peahens find it attractive just arbitrarily. And so if a female prefers to mate with males who have a colourful tail, then her sons are likely to inherit this colourful tail as well. And so they'll be more attractive to females when they grow up because females prefer this and they'll leave more offspring. This idea is called, I'm not joking, sexy sons, because it's not about the sons being healthy or better at surviving, it's just about them being better at reproducing because they have this trait that females find attractive. So it's circular in that way because the preference itself selects for the preference to be continued in future generations, even if it's not helpful for any other reason. And again, we don't have to say anything about females deliberately calculating this when they choose a mate. It's just that if we have a population where some randomly prefer one thing and others prefer something else, if any preference has a beneficial effect and is heritable, then that will be selected for. So to sum up, we've seen two reasons that females might benefit by being choosy with their mates. Essentially, good genes is about helping their offspring in natural selection, and sexy sons is about helping them in sexual selection. You've probably noticed that we've been talking only about females choosing mates and males trying to be chosen, and you might be wondering why that is. Well, the fact is, it is more often females who are the choosier sex, and I will explain why. We define females as the sex that produces large gametes, eggs. By contrast, males are the sex that produce small gametes, sperm. In most species that have two sexes, so that's humans as well as almost all other complex animals, the female sex physically invests a lot of time and resources in producing offspring. For instance, through pregnancy, childbirth, breastfeeding, providing parental care, laying eggs that provision the developing embryo. And all of these do have a cost that can be measured in terms of calories required, and sometimes in terms of negative health consequences. And if you think of a pregnant woman, she's not going to get more pregnant if she has more sexual partners. She's still going to have just the one baby. So if a female wants to have as many surviving offspring as possible, the limiting factor for that is more likely to be the rate at which she herself can physically produce them and care for them, and not the number of sexual partners she's able to find. On the other hand, though, if you're a male and you have multiple sexual partners, you could, in theory, double or triple the number of offspring you have, because it isn't you that has to put in that physical investment. So this means that, generally speaking, males might benefit from having more mates, because that gives them the chance to have more offspring. And females might benefit from making sure they get the best mate possible in order to not waste their investment on someone who isn't going to give a very good genetic contribution. So that might mean females being more choosy and rejecting lower quality mates, and it also might mean competition between females for access to the higher quality mates. This is an oversimplified story in many ways. For instance, it doesn't take into account that in lots of species, males provide parental care as well as females. And so in that case, males would also have a relatively high cost of reproducing. But it does illustrate why in many species you see females being selective about who they mate with, and males just trying to mate a lot in a way that's not as selective. One really interesting exception to the general rule that females invest more in offspring is the small number of species where males are actually pregnant instead of females, most famously seahorses. We know they're males because they're producing sperm, but instead of the males passing sperm to females, it's the other way around. Females give their eggs to males to be fertilized, and the male carries the developing embryos in his body. And as you might predict from what we're just discussing, in these species, males are choosier about mates, since they're the ones who do the bulk of the investment. Earlier biologists thought that, because of the logic I've just talked through, with females being generally more choosy, you'd expect females to be naturally monogamous. However, we've recently learned that this isn't always the case, and there are lots of situations where you get females actively seeking out multiple mates. The reasons this might be beneficial are a bit more subtle for females than for males, but for instance, you might have more genetic diversity of your offspring, which is beneficial if they come from more than one father. Or you can mate multiple times in order to conceal paternity, because if every male in your group thinks your child might be his, then he might treat you better. This realization that females frequently mate multiple times has really revolutionized the field of sexual selection in the last few decades. One consequence is the idea that sexual selection can actually continue after mating has already occurred, because there might be sperm from more than one male present in the reproductive tract of the female. And that's especially the case in the many species where females can store sperm and keep it to use later. So as a male, you're not just competing for access to mates, but your sperm might then have to compete with the sperm of other males to fertilize eggs. So in this illustration, the green male has invested twice as many sperm, so that might make him more successful this time, but possibly leave him with less sperm to invest another time because it takes time to replenish. He could also have some proteins alongside the sperm in the seminal fluid, which can help in postcopulatory competition, helping his own sperm along or even altering the behavior of the female. And this is a really interesting new area of sexual selection research, studying the strategies used to succeed in postcopulatory selection. And something that we know even less about is the idea that females have adaptations to favor the sperm of certain males over others. So that's a really exciting open area of study. Another development in the field has been an increase in interest in the strategies used by females to succeed in sexual selection. Back when sexual selection was first described by Charles Darwin, he defined it as selection resulting from a struggle between males for the possession of females. And this view that the male is the agent in sexual selection and the female is essentially the passive prize persisted for a long time. However, we know that this is far from accurate, that females do much more than just sitting there waiting for males to fight it out and mating with the winner. We've already seen in this short presentation how females can benefit from being actively choosy about who they mate with, competing with other females, seeking out multiple mates, deceiving males about paternity, and possibly even continuing to be actively choosy after mating has occurred. So looking at these strategies used by females in particular is a growing area of study, and it's something I myself work on and I'm really, really interested in. Hopefully with this brief introduction, I've managed to convince you that sexual selection is an interesting area of study, and that even though it was first described over 150 years ago, there are still lots of exciting things to discover.